Okay, good morning. Welcome to
FamilyMath number 461.
FamilyMath461. So today we're going to talk about bases, and we're going to do a fun project about base 3 halves. Now it turns out you did this base 3 halves project in your school, right? Mm-hmm. And oh, that's fun. So I learned this idea from James Tanton, and it sounds like your teacher did too, because she used the phrase exploding dots, right?
Yeah.
Yeah. So I think that's. She must know, be familiar at least with his work. So that's really cool. It's a small world. So we're going to start by remembering how we look at base 2 with blocks. I did this with both of you guys long time ago. But can you explain to me even what base 2 means?
Well, base 2 is you can only have 2 digits. You can have a 1 or a 0 for each place.
Uh-huh.
And the places are the 1's digit, the 2's digit, the 4's digit, the 8's digit, and all the powers of 2 digits.
Yeah. So which blocks do you want to represent 1s and which ones do you want to represent 0s?
You can have these represent 1s.
Alright, so the greens are 1s and the purples are 0s. So just make a 4-digit number.
One 0 0 1.
Alright, so this is the number 1001 in base 2. And actually base 2 has a different name. Do you know what it is?
Binary.
Binary. Yeah, did you know that?
Yeah.
Yeah, okay. And it turns out there's actually kind of a fun way that you can add numbers with blocks in base 2. So make a different 4-digit number above this one. Leave that one there.
So you can do
above it.
1 1 1 0 1
1101. Okay. And we're going to add these together. This plus this. And what's the obvious way to add it together?
Well, we add the digits.
Okay.
So
just
we can
say 2,
2
1, 0, 2.
0 2.
Okay, so that's the obvious way to add it. So 1101 plus 1001 is 2102. Can you just double check this on camera?
Yep.
Okay.
It is.
But what's the problem?
We can't have
these.
Yeah, so we're not allowed to have stacks of 2 here. And what happens when you have a stack of 2?
Well, the number 2 is 1 0, so you can shift it over.
You shift it over.
0.
So 1 there, and there's nothing there.
Okay.
Yep, and then you can do the same thing. That would be 1 0.
1 0.
So we get 1 0 1 1 0.
Yeah, so the neat thing is anytime you have a stack of 2, you just turn it into a 1 0. And the blocks seem to be able to add, and actually do just about anything, in binary. You can even subtract, but there, when you subtract, you end up with a -1, so you have to figure out what to do with the -1. But let's see, let's prove, not prove, but let's demonstrate to ourselves that this actually works. So the number 1101, remember this is the 1s, 2s, 4s, 8s digit. So what's this number?
Well,
1101.
13.
So it'd be 13.
Plus 9.
9.
Plus 9. So what do we hope that is?
22.
22.
This would be
And this has a bit in the 16s digit.
16.
16
plus
plus
6
yep,
is 22.
16 plus 6 is 22. So the neat thing is, in this way of thinking about binary numbers with blocks, the cool thing is the blocks seem to know how to add in binary, which is crazy, right?
Yeah.
That's pretty cool. But now we're going to talk about base 3 halves. Okay?
Alright.
Okay.